Hi friends, this is Khatroth Rajesh. My roll number is 29518156, branch aeronautical engineering, and subject is aerospace structural dynamic. Today we are discussing about the identification method of model parameters of machine tools under periodic cutting excitations. So, come to introduction. This presentation provides a methodological approach for model parameter identification of machine tools under periodic cutting excitation. The accurate estimation of model parameters is crucial for the dynamics analysis and structural health monitoring of machine tools. This approach combines experimental model analysis and signal processing techniques to extract the model parameters from the measuring response signals. The identified model parameter can be used to assess the dynamic behavior and stability of machine tool. Come to machine tool dynamic. Understanding the dynamic behavior of machine tools is essential for improving their performance and reliability. The model parameters include natural frequency, damping ratio, and mode shapes play a crucial role in characterizing the dynamic response. This presentation focuses on the identification of model parameters using a methodological approach that combines experimental model analysis and signal processing techniques. Accurate estimation of these parameters enables the assessment of vibration characteristics and stability of machine tool. Come to experimental model analysis. Experimental model analysis is a widely used technique for identifying the model parameters of machine tools. It involves existing the machine tool with a non-input signals and measuring the corresponding response signals. The collected data is then processing using various signal processing techniques to extract the model parameters. This presentation discusses the experimental setup, data acquisition, and signal processing methods employed in the model parameters identification process. Come to signal processing techniques. Signal processing techniques are employed to analyze the measured response signals and extract the model parameters. These techniques include frequency domain analysis such as FFT, power spectral density estimations, and model parameter estimation algorithms. The presentation covers the application of these techniques in identifying the natural frequencies, damping ratios, and mode shapes of machine tools. Accurate model parameters estimation is crucial for assigning the structural integrity and dynamic stability of machine tool. Come to parameters identification approach. The proposed methodological approach combines experimental model analysis and signal processing techniques for the accurate model parameters identification of machine tool. It involves existing the machine tool with periodic cutting excitations and measuring the corresponding response signals. The collected data is then processor using advanced signal processing algorithms to estimate the model parameters. This approach enables the assessment of these dynamic characteristics and the health condition of machine tools under cutting conditions. Come to experimental setup. The experimental setup for model parameters identification of machine tools include the attachment of sensors to the machine tool structure. These sensors measure the response signals during cutting excitations. The sensors can be accelerometer, strain gauge, or displacement transducer. The accurate placement of sensors is crucial for capturing the dynamic behavior of the machine tool. This presentation discussing the selection and placement of sensors in the experimental setup. Data acquisition. Data acquisition is an important step in the model parameters identification process. It involves collecting the response signals from the sensors attached to the machine tool during cutting excitation. The acquired data is typically in the time domain and needs to be processed further the model parameters estimation. This presentation discusses the data acquisition techniques, sampling rates, and consideration for the capturing the dynamic response accurately. Model parameter estimation. Now come to model parameter estimation. Model parameter estimation algorithms are employed to extract the natural frequencies, damping ratios, and mode shapes from the acquired response signals. These algorithms utilize advanced signal processing techniques such as autoregression modeling, frequency domain decomposition, and subspace identification methods. The presentation covers the theory and implementation of these algorithms for accurate model parameters estimation of the machine tool. Result and analysis. The identification model parameters provide valuable insights into the dynamic behavior and stability of machine tools. The presentation discusses the analysis of the obtained results, including the interpretation of mode shapes, assessment and of natural frequencies and evaluating of damping ratios. The analysis of model parameters helps in identifying potential issues such as vibration induced tool wear and the charter stability and the enables the optimization of machine tool design and machining process. Finally, the conclusion. In conclusion, the methodological approach presented by in the study enables accurate model parameters identification of machine tool under periodic cutting excitation. The combination of experimental model analysis and signal processing techniques provides valuable provides valuable under periodic cutting excitation. Dynamic behavior stability identification machine tools under periodic cutting edges. The combination of experimental model analysis and signal processing techniques provide a valuable insights into the dynamic behavior, stability, and health conditions of machine tools. The identified model parameters can be utilized for optimizing machine tool design, improving machining processes, and ensuring the structural integrity of machine tools. Thank you.